let's solve homework exercise number 1 from section 3.7 homework exercises. Use a truth table to determine if the following symbolic form of an argument is valid or invalid. Okay, so what we have to do is, to do the truth table, we have to take the two premises which are above the horizontal line, if P then Q, okay, conjunct it with the other premise, not Q, and then put those together. Does that imply the conclusion not P? Okay, premise number 1 and premise number 2, does that imply the conclusion? We're going to do a truth table for this statement, and if it's all true, if it ends up a tautology, then the argument is valid. If you don't get a tautology, then the argument will be invalid. So what we have is we have P and Q, and we start out with true, 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 false, false, true, and two falses, right? Okay. Okay, first one we'll do is order of logical operations. We'll do the negation of Q. So that changes Q from true to false and vice versa. So it becomes false, true, false, true. Okay, now we're going to do inside these parentheses, if P then Q. Okay, if true then true is true. If true then false, we broke our promise. That's the only time an if then is false. And if the if part is false, it's automatically the if then statement is true. Okay, because it doesn't matter, because the if part, we didn't do what we're supposed to, so it doesn't matter whether we follow through or not. So it's kind of true by default. Anyway, for if P then Q, the only time it's false is in the second row. Okay, now we're going to do our third step is we're going to do what? The third and fourth columns with a conjunction, right? So now we've got if P then Q and not Q, right? We're doing that. Now again, this is in the third column, fourth column, this is in the third column, right? So false and true is a false statement, right? Only time an and is true is when both are true. True and false is a false statement. False and true is a false statement. And true, that's the only time when an and is true, okay? So now we've got this whole statement, and we're going to imply, and then we got to do imply with the negation of P. So we'll take another step to do the negation of P over as the conclusion. So then changes the values of P from true to false, so we end up with false, false, true, true. And now we're finally going to do our entire statement, right? It's an if-then statement with column number 1, 2, 3, 4, 5. Here's our if-then, right? So column 5, does it imply not P, which is column 6? That's our entire statement. So we have it right here. So if false, then false is a true statement. If false, then false is another true statement. If false, then true is a true statement for an if-then, and if true, then true is also a true statement. Notice, for the entire statement, our last line is all truths. It's a tautology, meaning the argument is valid. Okay? So that's how you would do that by a truth table. So finally, from that work, we get the argument is definitely valid. Now, you can also, from the table for the standard forms of arguments on page 186 of your textbook, it states that if you've got if P then Q, an if-then statement, you got the negation of the conclusion. Therefore, you can conclude the negation of the antecedent, or the if part. That's called contrapositive reasoning, because if the conditional is true, the contrapositive of the conditional, which is if the contrapositive of if P then Q is what? Not Q, then not P, right? So you can see if you got not Q, then you got not P. So this follows one of the standard forms for valid arguments, so you could say it's valid by just matching it to that standard form. So you don't have to do a truth table. Okay? All right. Number 2, we have determine the argument is valid, or you may compare it to a standard form. Now, notice in this one, we have in a standard form is if you've got if P then Q, and you're given Q, and then you try and claim the antecedent P, that is the fallacy of assuming the converse. It's a fallacy, which means that it is one of the invalid arguments. Okay? It's a fallacy. It's one of the 4 standard invalid arguments. Now notice, this form is in your textbook, but if you just go ahead and change the Q to not Q, right, and have a not Q there and a not Q there, therefore P, you basically have the same argument, so you can just replace the Q with not Q's, and you still have the fallacy of assuming the converse. So this is definitely invalid. You don't have to do this one with a truth table. You can say it's invalid because it follows one of the forms for an invalid argument. All right, very good. Okay, we're going to go ahead and stop this session at exercise number 2. If you have any questions, send me an email through the inbox, through the Canvas course at the FSW portal, and I'll be more than happy to answer your questions. Again, this is your instructor, Dr. Swears. I hope you found this video helpful. Thank you.